Hey Algebra 1, so day 6 video here, we're going to be working on linear systems. So if you will go to your Delta Math and log in, and let's look at this last section. I've tried to do about half of each of the sections, and you can contact me if you get stuck on any of them. I can, send you another link or two, or make another video, or Zoom with you, or whatever you need, but just communicate with me directly, and I'll be happy to help you with whatever you're stuck on. So it says solve the following system of equations graphically on the set of axes below, plot two lines by clicking the graph, then click the line if you want to delete it. So here's the goal here. Our goal is to graph both of these lines and find the point where they have in common, the point where they cross. There's three possibilities with systems. They either cross at one point, they either don't cross at all because they're parallel, or they're the same line secretly. Maybe one of them's in standard form, or maybe after simplification you figure out that they're talking about the same line. That would mean the answer is infinitely many. So we have one solution, no solution, or infinitely many for these two lines. So we've got to use slope-intercept form to really graph these well. -4, that's our y-intercept for the first line, so we're going to click there at -4. And then the other value, -3/2, that's our slope telling us to go down 3 and right 2, and that'll tell us where the next point is. Now this is really avoiding a lot of input-output as a process of graphing. For example, if you were to plug in 0, the x value would be plugged in 0 times -3/2, which would be 0, and 0 minus 4 is -4. And so as you go to calculate other values, let's plug in 1 for x, let's plug in 2, let's plug in other values. Basically, when you plug in 2 here, the 2's are going to cancel out, and you're going to be left with -3 minus 4, which produces -7 as an output. So we're looking for all these different points that x would go in, y would come out, and it would show us all of the input-output points that create this line. But you can kind of study the structure of the line and the values used in the equation to graph it really quickly using what's called slope-intercept form. So let's try that with the second one. If you were to plug in 0 for x, half of 0 would be 0, and if you subtract 8, you get -8. That concept of the c value, this value in the very back here, you can always start on the y-axis at that point. And so now it's telling us +1/2. That means rise 1, run 2, and now we have this point that they have in common. It says you may only graph two lines, so I must have accidentally clicked it twice. But basically, I'm looking for that point right there, 2, -7. That is the solution to the system. And they're probably asking for it here. So they want it most likely as an ordered pair. So I'm going to do a parenthesis. Let's do 2, -7, and let's see what it likes as my answer. It likes it. Okay, I've graphed it correctly. There's my -3/2 minus 4. Here's my 1/2 x minus 8, and then my point where they were intersecting created my solution. So let's look at another one. So we're going to use that same quicker graphing system here, starting at 4, +4 this time. Let's go down 1 and right 6. And I did that because this value was negative, so we want to see that line going down over time. And the other line starts at +1 and rise 1, run 3. So for example, if I was to plug in the value 3 here, 1/3 of 3 would be 1, and 1 plus 1 makes 2 as the output. And so you can do that again, rise 1, run 3, and you'll see this other point that they have in common, 6, 3. That is the solution to the problem, 6, 3. Again, as an ordered pair with parenthesis and a comma in between them. And there we go. So let's just kind of knock out a few more. Let's start at -8, rise 2, run 1. Let's start at 4 as the y-intercept, and let's go down 1 and over 1. So again, you have one positive slope, one negative slope. They're crossing at what looks like to be 4 for the x, and then because it's on the axis, we'll say that's 0. So 4, 0. Okay. And so I'll leave you to do the other two. So now let's talk a little bit about substitution. So substitution is the concept where you're solving not by graphing, but you're trying to put these two together. So I'm going to take this into my other software for a moment. So when we're talking about substitution, we really want to lock in on the fact that one of the equations is solved for the variable x equals. We have one of the equations where one of the variables is completely by itself. And so that means for this other side, this y plus 1, we can use that in the other equation wherever we see x, because x really equals y plus 1. Those are synonymous, meaning they're equal to each other. They're equivalent. You can use either one. And so I'm going to basically show you, if you take this top equation and instead of using x, don't use x, replace it with what x equals. It equals y plus 1. And then we'll want to use a common algebra skill called distribution. These are up against each other, so we're going to distribute multiplying -3 times y, also -3 times 1, and that will produce -3 minus 3, rewriting the rest of it. And now we have continued to combine like terms, -3y plus 4y, that'd be positive 1y, and then keep your -3, keep your equals, keep your -1, and then we'll add 3 to kind of cancel that out. We want to move that over to the other side, and that would ultimately produce 2. And so what we want to do here is we want to take that 2 value, because again there are lines that are crossing in a grid, so we want x and y, and we want to basically plug that value in where we can go up here and say, okay, well, if x equals y plus 1 and y is supposed to be 2, well, 2 plus 1, that really means we're talking about the number 3 here. And so once we have the point 32, that's kind of the answer. That is the final thing that I'll type in on the other page as the solution. And I can even know if that's correct using either equation. If you replace x and y and do the math on it, you'll see that it comes out to be something correct. And so let's go ahead and go back to the other page. And I'm going to do 3 in the first one and 2 in the second one. And let's see what we got. And that one is correct. And then it's going to just show you those same steps that I just explained. Let's try another one. So I'm going to do the same thing. I'm going to take a picture of it. Okay, so what I just did in 2 steps, looking at this system that they wanted me to solve, basically they were both equal to y in this one. So I was thinking, okay, well, y really equals 2x. And so that 2x can replace the y in the other equation, and basically setting each of the parts with x equal to each other. And so just kind of walking through the steps for solving that. I have another video for these in terms of solving variables on both sides and all that. But basically we want to subtract this 4x to the other side. And 2x minus 4x gives me -2x. Equals in the middle doesn't change, and then -8's the only thing left on the right side. And then this needs to be divided over. We're trying to do opposite operations. Currently these are multiplicating. These are represents multiplication. They are multiplying. So I'm going to divide that negative over, and negative over negative gives you 4. So now I want to plug 4 in. You could plug it into either one. I thought real quickly 2 times 4 gives you 8. That's one way to really quickly get it. Or you could say, well, 4 times 4 is 16. Well, then minus 8, you're still getting 8 as an answer there. So that's really comforting to think I must have gotten it correct. 4, 8 is my solution. And so let's go in here, 4, 8, and submit our answer. And I bet it's going to love it because we've already checked it. So let's back up and check a different section. Let's check some elimination. Elimination is more of a concept where you're trying to add the 2 together. So I'm going to pause the video. So now that I have it in my software, I want to talk a little bit about how these are both in a different form. Like when you're graphing, they're both y equals. In the substitution, you had like one that was y equals or one that was x equals. I know one of them had y equals for both of them, but you can really do the problems in all 3 of these different formats. But when they're both in standard form, meaning they have x and y both on the same side and they equal a constant on the right, x and y are together, we really want to think about, well, is there a way we could multiply one of them where they would be the complete opposite value? For example, if -6 is here, I could make this somehow a +6. Or if this is a 4, maybe I can make this value a -4. And you can really use multiplication in any way to accomplish this. And so I was kind of thinking, let's multiply by 6. Let's see if it'll let me type that. Yeah. So let's say we multiplied this top one by 6. That would produce a 6x here, and then a -12y here, and then a 54 when we multiply the 9 also. So you kind of multiply all the way through. Well, now I now have basically all of these changed, and I rewrote the top one, -6x plus 4y equals -46. I wrote that below it. And so now let's add these together. If we were to add these two together, that's going to eliminate and give you 0. But as we add the other side, -12 plus 4, that gives you -8 for the coefficient of y. 54 plus -46, that gives you 8 here. And then if we divide, we'll figure out that y has to be -1. So now let's talk about how to accomplish getting the other value. You know, it's a point, so you have to have x, you have to have y. And so let's take -1 and replace it for y in that top equation. -2 times -1, that makes +2. And then what number plus 2 is 9? Let's subtract that 2 over to figure out that x is 7. And so final answer, xy, x is 7, y is -1. Let's type that in here, 7, -1, if I remember correctly. Yeah, got it. It's just going to walk you through the same process. Now, actually, they wanted to cancel here. They see that it was a +4y. They say, well, if I multiply this, you'll get a -4y here. So basically, when they do it, it's going to work out the same, but they're going to solve for x equals 7 first. And then when they plug that in, they're going to end up getting -1 for y in the second part. So there's kind of a demonstration of both. Let's do another one of those. So now that I've got this one on my sheet of paper, theoretically, kind of walking through what you should have on your sheet of paper. On this one, I think I really am targeting the y position because I've got 14 and 2. And, you know, 7 times 2, that would be 14. And so I'm considering multiplying this second equation by 7. So let's see what that would look like. I don't know if I was going to let me just redo it, but I guess not. So if I multiply everything by 7, let's multiply this one all by 7, and that's going to give me -14x minus 14y equals 56. Okay. So the reason why I'm doing that is because 7 times -2 makes -14y. Up here I have +14y. I wanted to add these together, and I just noticed that this should have been -56 because 7 times -8 is -56. So I'm going to rewrite the other one, 7x plus 14y equals 35. And my goal here is to add the two together. And so let's think about when I add 14 and -14, that's the really kind of the main point here that's giving me 0. -14 and 7, that's giving me -7x. Sorry, it's wanting me to do the lines there. -7x, and then over here, if I'm to add these two together, I'm going to get -21. Let's divide that -7 over, and x equals 3. And so we want to take that x equals 3 and we want to replace it in one of these equations where the x is, and basically try to solve for what the other value would be. So let's just use the top one, you know, 7 times 3, that value is going to give us 21. We still have the 14y, we still have the 35. And move that over to the side here. So I'm doing 3 times 7 to get 21, rewrote the rest of it. Let's subtract 21 over to this other side, so not here but there. And that would be 14y equals 14, and 14 divided by 14 is 1. So I'm looking for 3, 1 as an answer for this one. Quick check to make sure it works. Let's see, -2 times 3 is -6. And -2 times 1 would be -2. That does give me -8 if you replace those values. And so we're good to go. All right, so I think that's going to pretty much end this particular video. I'm going to jump off and do another video for the next 3. So I'll see you then.